The wall behind you may one day power the room in front of you. Not a battery in the basement, not a giant metal box, but the bricks themselves. Scientists have discovered that a cheap red brick can become a supercapacitor. It sounds impossible because bricks are supposed to be dead weight. But inside their pores is the hidden doorway to energy storage. This is not science fiction. It is chemistry, architecture, and electricity colliding in one ordinary object. And if it scales, buildings could stop being only shelters. They could become energy reservoirs. The revolution begins with clay. The world is adding solar panels and wind turbines faster than old grids can adapt. But clean power has one brutal weakness. It does not always arrive when we need it. Batteries solve part of the problem, but they need space, metals, cooling, and money. So engineers are asking a stranger question. What if the storage was already built into the building? Every wall, staircase, and facade could become part of the electrical system. That idea changes the meaning of infrastructure. It turns passive materials into active machines. And the most surprising candidate is the humble red brick. Fired bricks have been used for thousands of years. They are cheap, strong, common, and almost invisible to us. But their red color comes from iron oxide. That iron oxide became the key. Researchers used it to help grow a conductive polymer called PEDOT. PEDOT forms tiny fibers that coat the inner surfaces of the brick. Suddenly, a rough construction block becomes an electrode. Add an electrolyte, connect wires, and the brick can hold charge. It is not a normal battery. It is closer to a supercapacitor built from something sold by the pallet. Batteries store energy through slower chemical reactions. Supercapacitors store charge mostly on surfaces. That makes them fast. The more surface area they have, the more charge they can hold. A red brick is full of tiny channels and cavities. The polymer coating turns those hidden spaces into electrical storage zones. Each brick is small, but walls are not small. Stack enough units together and the wall becomes a modular storage system. The building material becomes the device housing. That is the genius of the idea. The first use would not be powering an entire skyscraper overnight. The first use could be emergency lighting. A wall charged by solar panels could illuminate exits when the grid fails. Homes could store small bursts of power inside walls. Remote buildings could use them where battery maintenance is difficult. Disaster shelters could keep radios, sensors, and lights alive longer. Smart cities could hide storage inside ordinary urban surfaces. The less visible the storage becomes, the easier it is to deploy everywhere. That is why this invention matters beyond the lab. It does not ask people to accept a strange new object. It upgrades something the world already manufactures at massive scale. That changes the economics of imagination. Instead of adding storage after construction, storage could become part of construction. Buildings would no longer be energy consumers only. They would become energy participants. This could support microgrids, solar rooftops, and resilient neighborhoods. The biggest promise is not one brick. The promise is millions of them working together. In energy storage, scale is everything. And bricks already have scale. But this technology is not ready to replace lithium-ion battery. Its energy density is still limited. A brick can store charge, but not magic. Moisture, Durability, wiring, safety codes, and manufacturing consistency all matter. A wall must survive, whether before it can survive as a power device. The polymer must remain stable for years. Electricians and builders would need new standards. Fire safety, insulation, repair, and recycling would need careful design. The exciting idea must pass boring tests. That is how real technology earns trust. The deeper story is not about one clever material. It is about rethinking the objects we ignore. Roads could collect energy. Windows could generate power. Walls could store it. The future grid may not be one giant machine far away. It may be millions of silent surfaces around us. That makes the brick feel different. It is no longer just the thing that holds up a building. It might become the thing that keeps the lights on.